Okay, let's talk. So you got some framework for the situation. Mathematically, what's happening in this situation? What's happening to the number of people that... No, so you're way ahead of the game here. So just, what's happening to the number of people that know the secret? How is it increasing? Doubling, right? Times 2. Okay? So every day, that number doubles. So they're introducing 3 different ways to look at this value of how many people know the secret on a given day. So decimal notation, that's just a value. That's just a numerical kind of final answer. Product notation is showing the process of how we started from day 1 up to whatever current day and what happened in order to get this number of people. Okay? I think product notation, in terms of conceptualizing the type of growth we're talking about, product notation is the most important for us. Okay? This is the most important. This is what's happening behind the scenes. All right? When something's doubling every day, this is what happens. So how many days? So we started with 3 people. We multiply by 2 4 times. How many days went by? 4 days, right? So that's what happened from the beginning in order to get, after 4 days, how many people know the secret. All right? But suppose it was after, 17 days. What do we have to do product notation? It'd be 3 times 2 product notation. Times 2. Did you want to get out of here on time? Right? 17 twos, okay? So we could do that, but we don't want to write, that's 17 twos together. So we have an exponent to save us. All the exponent does is just give us a short way to write this, right? It'd be 3 times to the 17th. So when you see that, your image immediately, your understanding has to be, oh, that's 17 twos multiplied together, or doubling every day for 17 days. Okay? So we want to really be able to see that. So we're going to see lots of expressions like this, but you have to look at that and imagine the product notation. What's going on here, right? What's going on? Okay, so you're building this table, and we've got in this situation, what is the input? We're moving towards building a function. What will the input be? X, input. So this is input. So given a day number, we want to know what's the output. Number of people. So which column is that? The second, the third, or the fourth column? Which column is the output? Second, third, or fourth? People are saying second. All of them. These are just 3 different ways to represent the same output value. All of them are the output. Okay? So all of these are output. Okay, so you said it's doubling, right? So when we talk about doubling, this is really important how this works. So are we doubling the input to get another input? Or are we doubling the input to get the output? Or are we doubling the output to get the input? Or are we doubling the output to get another output? So everyone, don't answer, just think about it. So we're doubling what to get what? Everyone think about it. We're doubling what to get what? Okay? So what is doubling and what does it give us when we double it? Really crucial here. So volunteer. We're doubling what to get what? Right here. We're doubling the input of the function to get another input of the function. Agree? Someone agrees. Someone doesn't agree. Adam, what do you think?
I'd say we're doubling our output to get another output.
We're doubling our output to get another output. So nods here. We're doubling the output to get an input. So we got all kinds of choices here. This is really important. to understand these functions. What's getting doubled, and it's giving us what? So, let's start with here. So here, x equals 2, right? X equals 2. Are we doubling that number? No. So we're not doubling the input. So we're doubling the output, right? So here we go. So here's an example of output. Output's 12. And we're going to double it. And when we double 12, we get 24. Is 24 an input or an output? Output. What's getting doubled? The output is getting doubled to give us the next output. Really crucial to understand these functions. The output's getting doubled, and what does it give us? It gives us the output the next day. You see? We doubled one output, we get the output the next day. And that's why each output in product notation has what? When you go to the next one, it has what? One more 2 than the previous, right? So each time you go through product notation, when you go to the next output, you always have one more 2 than you did the previous. That means we're doubling the output to get the next output. Okay, so if we want to call that function f, is that what they called on the next page? So the input is what? X. Well, before we do this, so here on the 15th day, what will the exponential notation be? We'll have 3, and then there'd be 15 2's multiplied together here, right? 15. So it'd be 3 times. So notice what happens. On the 15th day, the total number of people is 3 times 2 to the 15th. So on the xth day, it will be 3 times. And what does 2 to the x mean? What does 2 to the x mean? You should be able to articulate that. Explain what that means. 2 to the x. Tell the person next to you. You're multiplying what? Multiplying by 2. How many times? X times. X, right? So don't be afraid of using a variable just like use a number. You're multiplying by 2, X times together. Okay, see you Wednesday. Oh, homework. So web work isn't up yet. Watch for an email from me, and then depending on what the web work is, you may have more time. Just watch for an email.